we have this handout link for you. The first page here is pretty simple, pretty straightforward. The second day gets a little bit more involved, but an indeterminate form means you don't know what the answer is just by looking at it. These are the list of all of the indeterminate forms. And so if you see infinity over infinity, you can't just say those cancel out, that's equal to 1. There are different degrees of infinity where that just is not true. You were also lied to before when somebody told you, oh, 0 divided by anything is going to be 0. And then they told you before that, hey, when you divide by 0, that's going to be undefined. Well, when you put 0 over 0, you can't have an answer of 0 and undefined at the same time, right? So it makes sense to me that these things here, something has to give where that's not going to be your normal gut instinct answer. Okay, so strictly today what we're talking about is 0 divided by 0 or infinity divided by infinity. So if you have one of these two forms, that means you can use this guy called L'Hopital's rule. L'Hopital's rule is something actually really simple. It just says if you have 0 over 0 or infinity over infinity, what we're allowed to do is take the derivative of the top and the bottom separately, and then you look at what the problem is going to be. All right, maybe you could plug in at that point and it's no longer in indeterminate form. So this very first example right here, I have this worked out two different ways. The first way is what we learned in the very first chapter of the year, where you just do a GCF, difference of squares, factor stuff out. We just factor and cancel, you use algebra, and then you can plug in, right? The second way is L'Hopital's rule form, where if you take the 5 and plug it into the numerator and the denominator, you get 0 on the top and the bottom. So if it's 0 over 0 or infinity, I can use L'Hopital's rule. Here's how L'Hopital's rule works. Don't take the derivative of that whole fraction. You're not going to do some crazy quotient rule there. It's not that complicated. You do the derivative of the top by itself. So the derivative of that 3x minus 15 is equal to 3. And then you do the derivative of the bottom by itself. The derivative of that denominator is just 2x. And now you're right here. And now you could plug in. It's not an indeterminate form any longer. You could just take the 5 and plug that in. And we're going to get the 3/10 for that. You get that same answer. So that problem I could have worked out either way. There are a lot of problems out there where we don't have limit techniques, except once we learned this L'Hopital's rule, right? So I'm telling you, your earlier techniques that you learned in the first chapter are not going to help you on all the limit problems there, but you combine that with the chapter 1 techniques and plus this technique here where you're doing L'Hopital's rule, we're going to be able to do all of our limits, all right? So if you look at this second example now, if you plug this 0 in, e to the 0 is 1. 1 minus 1, you get 0 on the top. And if you plug in 0 on the bottom, you also get 0 on the bottom. And so I'm going to apply L'Hopital's rule because it's 0 over 0 format. So if you do the derivative of the top, you get this 2e to the 2x. Go e to that power times the derivative of the power. If you do the derivative of that bottom, that x, that's just equal to 1. And now you can take 0 and plug that in, and you're going to get that answer of 2 right there. All right, so as we look at this one, this is just another example. If you plug in infinity, just think like you're plugging in a very large number. So infinity squared, that's like a billion squared. You get a huge number on the top, you get infinity on the top, and then e to the infinity, you get infinity on the bottom. So since you have infinity over infinity, that's L'Hopital's rule form. That's indeterminate form, which I can use L'Hopital's rule on. So I'm going to take the derivative of the top and the bottom. I get a 2x on the top, e to the x on the bottom, and now I plug in. So when I plug in at this second step, I still have infinity on the top and infinity on the bottom. It's still an indeterminate form. And so, but since it's infinity over infinity, I can use L'Hopital's rule another time. And then so you do the derivative of the top, which is 2. The derivative of the e to the x on the bottom is also just e to the x again. And now when you plug in, you got 2 on the top, which is just a number. This symbol here is supposed to be just like a number on the top over infinity. So if you have like 2 over a billion, 2 over a trillion, right? That limit answer is going to end up being 0 right there. And then this next example is just the same type of thing. That's just another example for you. I just want to stress if it's not 0 over 0 or infinity over infinity, it doesn't make any sense to keep going and keep taking derivatives, because then you're just taking derivatives just for the heck of it, right? Also going up here, you're not doing the derivative of that whole thing like a quotient rule. You're just doing the top and the bottom separately. So make that simple for yourself. It's supposed to be a simple technique. Notice right here, so I got 0 over 0 for the first step. Did the derivative of the top and the bottom, got 0 over 0 again, did the derivative of the top and bottom. Now, when you look at here, don't take the derivative another time because it's not 0 over 0 or infinity over infinity. Now you're supposed to be able to plug in. So e to the 0 is 1, 6 times 0 is 0. So whenever you have a number over 0, that leads me to this guy right here. Whenever you have a number over 0, that's going to be some type of infinity answer. If you're approaching it from the right, use the positive infinity. If you're approaching from the left, use a negative infinity. So that just goes back to like your y equals 1 over x graph where you got like a couple hyperbola branches, right? So if I ask you like 1 over x, like 1 over infinity, from the right-hand side, you're going up to the positive infinity. From the left-hand side, you're going down to a negative infinity. So whenever you see a number divided by 0, that's going to be some type of infinity right there. All right, so there we go. We got infinity for that answer. And then the last one I just wanted to mention to you, like we had a trig identity of this one in the past where we just had memorized, where we made an XY chart to show that this is equal to 1. But I didn't really test over that too much. You know, we practiced that a little bit, but I knew once we learned L'Hopital's rule, if you ever forgot that identity, you can just use L'Hopital's rule on it. So if you plug in sine of 0 is 0, x is 0, so you do have 0 over 0 for this one. And if you apply L'Hopital's rule, the derivative of sine is cosine, the derivative of x is 1, and now when you plug in 0, the cosine of 0 is equal to 1. So that's just a little proof of our identity using L'Hopital's rule. You will prove this same exact thing using XY charts in the very first section of the year. So that's what the day 1 is. And the day 2, we'll talk about what to do if it's not 0 over 0 or infinity, if it's on these bottom 2 rows of that indeterminate form.